The TRIZ 40 Inventive Principles. Genrich Altshuller, creator of the theory of inventive problem-solving, better known by its Russian acronym TRIZ, analyzed thousands of patents and identified a group of 40 techniques that inventors used successfully to solve problems across different fields. To inspire new inventors in their problem-solving, I created this video illustrating one of these principles. Principle 31: Porous Materials. Make an object porous or add porous elements, inserts, coatings, etc. For example, pervious concrete. By changing the concrete formulation to make it porous, storm water flows through the pavement, diminishing pollution in nearby bodies of water.
In 2009, the city of Shoreview, Minnesota installed innovative pervious pavements in its Woodbridge neighborhood to help keep pollutants out of nearby Owasso Lake. These porous roadways allow stormwater to filter down through the pavement instead of running off the surface to storm drains and the lake. Minnesota DOT and the local road research board undertook a multi-year research study to evaluate how well the new type of pavement worked.
The study is really important because there haven't been a lot of permeable pavements installed in this market as public infrastructure. And so I believe practitioners are looking for this sort of information should they be considering the use of a permeable pavement.
Shoreview poured a 7-inch pervious concrete pavement over 18 inches of crushed rock and gravel that retains the stormwater as it seeps into the soil. Regular vacuuming keeps the surface pores unclogged. MnDOT researchers tested the pavement's performance over several years for water absorption, sound absorption, and ride quality. They found that the pervious pavement in Shoreview not only continued to drain stormwater effectively, it was also quieter and smoother riding than a traditional pavement. Researchers pointed to the pervious pavement's superior stormwater handling and lower life cycle costs as compared to traditional drainage structures. They found the new pavement type as an alternative worth considering for city streets, even without calculating the expected benefit of pollution reduction and improved compliance with the Clean Water Act.
I believe the value of this study is that it demonstrates that the permeable pavement was a valid approach to solving a particular type of public infrastructure challenge.
If an object is already porous, use the pores to introduce a useful substance or function. For example, Oleo Sponge. A regular sponge with an oleophilic treatment creates a tool to clean oils in and below the ocean surface.
In an oil spill, the gunk near the water's surface can be skimmed or burned off, but oil farther below is harder to get. Researchers with the Argonne National Laboratory may now have a solution, a sponge that absorbs oil in water. The researchers started with a polyurethane foam, similar to what's in seat cushions or your home's insulation. The problem was oil wasn't always sticking to the foam, so they tried putting metal oxide on the sponge's surface. Long story short, this layer attracts molecules that bind to both oil and the sponge at the same time. And better yet, the material can be wrung out and reused. The researchers haven't said if their invention is ready to clean up major oil spills just yet, but they mentioned a more reoccurring environmental issue. Oil tends to collect in ports and harbors as ships move in and out. The sponge could be used and reused for routine cleaning.
Share this video and add your examples of this inventive principle in the comments below. Porous materials. Make an object porous or add porous elements, inserts, coatings, etc. If an object is already porous, use the pores to introduce a useful substance or function.